Okay. We're going to start off talking about conditional probability and how to work with frequency tables. When we're working with our frequency tables, the probability of A and B happening is, Halvid, please focus. Okay, so question I have for you guys. When we were dealing with mutually exclusive, does anybody remember what this was? It was 0. And it was 0 because they could not happen at the same time. Do you agree? Okay. For us, when we're dealing with frequency tables, I'm going to put here or Venn diagrams. It is the overlap. The probability of them happening together is the overlap. Of course, it's over the total. Overlap over total. Okay, so I'm hoping this makes sense, because if you have an event that is mutually exclusive, I'm going to erase this in just a bit. Would you draw them like this, or would you draw them with overlap? So this would not be mutually. This would be mutually exclusive, and this is not mutually exclusive. Do you agree? So if the probability here is the overlap, does it make sense on why it's 0 for mutually exclusive, and it's the overlap on the other type of problems? Yes? Okay. All right. Next probability is P of A or B. Is there a difference when I'm dealing with the probability of A and B versus A or B? There is a difference. Okay. Can anybody think back in or look back in your notes from yesterday? What was it for the or? You add them. He is correct. It's the probability of A plus the probability of B. Now, it's not exactly the same. It is a little different. There's a piece at the end that we have to worry about, minus the overlap. Good job. Why? Because you would have counted it twice. If you do the probability of A by itself, the probability of B by itself, you're counting the overlap twice, so you subtract it to make it nice and good the way it should be. Got it? Okay. So I'm going to put overlap over total. Okay. Now, we are going to try one of the frequency tables. I'm going to make mine nice and big. Mine's going to be a 1, 2, 3, 4, 5 going down, a 1, 2, 3, 4, 5 going across. Okay. Okay, everybody has this down. You're writing it, drawing this with me. Thank you. All right, and across this way, we're going to have car, truck, van, and total. Okay, everybody ready? Now, so this is a parking lot. And there's no mixture of cars. It's not a car that's black and white. The cars are either black, silver, white, that's it, and they are car, truck, or van. No truck vans, no black, white cars. It's one of these colors or one of these types of vehicles. Got it? Okay, so I'm going to give you some numbers. This is 36 for a car that is black. A truck that is black is 28, and the total black is 80. All right, silver. I'm going to not give you the car, but I'm going to give you a silver truck is 6. A van that is silver is 2, and the total is 20. I'm going to go to the white column. I'm going to give you all of those. 52, 34, 14, and 100. And the last number I'm going to give you is the total in that bottom right corner. All right, figure out the other numbers. Take out your calculators if you haven't already. And I did tell you the other day we're going to be using them every day. So grab one as soon as you come in. Got them? Okay. First number here is what? 16. Did you add these two and subtract from 80? Same thing here. 6 plus 2 subtract from 20 is what? 12. I'm going to circle these just in case you didn't change colors like I did. You know which ones were given, which ones were not given. Okay, total for cars, 100. Total for trucks, and the total for the vans. And is 100 plus 68 plus 32, 200?
Yep.
And the sum of these across here also 200.
Yep.
Okay. Now, I do want to talk about mutually exclusive events here as well. If I walk into the parking lot, can I find a white van? How many white vans are there?
A lot.
Look at your chart.
There is 52. No,
14.
No, 14.
14 white vans.
Not that many.
Okay, I walk into the lot. Could I find a silver truck?
Yeah.
How many silver
6.
trucks? Okay. Looking just here, what's there the most of? White cars. Oh, I have a white car. So there are most white cars in the parking lot. All right. Which I don't like because I get out to the parking lot at the store and I'm like, oh, where's my car? Because there's a ton of white cars. All right. So it does. Taking a look here, does that make sense? Okay. Knowing what I said earlier, can I walk into the lot and find a black silver car? No. Is there a... No, you can't. In my world, in this little situation, no. Is there such a thing as a black silver car? Do they overlap at all? No. No overlap means they are what? Mutually exclusive. Could I walk into the car and say, I'm going to look for a truck van? No, right, it's not, it doesn't make sense. Do you agree? We're going to look for one, or we were going to find one. No, because they're what again? Starts with an M?
Hang on. A truck can also be a car, and so can a van.
They're vehicles. We're calling these vehicles.
Then why is car by itself the category?
Because a car is a car, where a truck is a truck, and a van is a
It
van.
means sedan, Hal.
Oh.
Okay.
Sorry, I just
okay.
want to poke holes in that.
All right. Shh, listening. All right, we are now going to look at probabilities. Okay, So what's the probability, we're going to call this number 1, what's the probability you walk into the lot and the car or white? What's the probability you walk into the lot and you find that it is a car or it is a white vehicle? So is this going to be white and car at the same time? No, because what would that word have been if it was and? Oh, I just gave it to you. If it was, if I was looking for a white car, what would I have put here? And. Okay, so I'm looking, what's the probability that it's either a car or it is white? So look up at your probabilities over here. What do we do? Probability of just the car, or we do plus probability it is just a white vehicle, and then minus the what? I'm just going to write the word overlap. Now, what's the total all the way around? So are you guys okay if we just make one big fraction with 200? You can make 3 individual fractions if you want to. I'm just going to make one. What's the probability it is a car? How many car total do I have? Plus, how many white vehicles total do I have? No, total white vehicles. 100. Do you see that? Total white vehicles is 100. Take away, overlap is white and vehicle at the same time. That was the one we talked about earlier, right? Here's white, here's car. White cars are 52. Why do we have to subtract it? Helvet, pay attention, please. Because we counted it twice. Did I count the 52 when I had this 100 right here? Did I count the 52 again when I used this 100 here? So I counted it twice. I subtracted. 100 plus 100 is 52. Sorry, is 200. Minus 52 is what? 148. Over 200. It looks like you could at least divide by 4 if you're using the baby calculators. Divide top and bottom by 4 and just keep dividing until you get it as small as you can. Or you use your fraction key. It reduces those of you that have it. Yes. Okay, give it to me. Okay. You're writing it as a percent. Before I get the percent, let me get the fraction. Okay, you had it also 37 over 50. Okay, now you want to be careful because I looked at the test and some of them say write as a fraction in reduced form. So if you have to write it as a fraction in reduced form, can I write it as a percent? No. So I'm going to get practice on this one, writing it as just a fraction.
If we write both down, are we going to get marked down?
As long as you have the one I asked for, you're okay. Okay. Just write them all, fraction, percents, decimals.
Yeah.
All right, number 2. What's the probability it is black or truck? Okay. The or word is there. Is that overlap? Yes or no? Am I looking for a black truck?
Yeah, overlap.
No. Okay, it's okay. Which one? What word is the overlap? It's and when I'm looking for the black truck. It says or, so what do we do? Probability of black plus the probability it is a truck minus the overlap. Okay, it's all over 200. And what do I do? What's the probability it's a truck? How many total trucks? 68 out of 200 plus, did I do that wrong? I did. I didn't, but I want to go in order. Black, I'm sorry. What's the probability it is a black vehicle? 80 out of 200 plus, what's the probability is a truck? How many trucks do we have? 68 out of 200 minus overlap is a black truck. Where do black and trucks overlap? Truck, black, right here, 28. Plugged it in your calculator, 80 plus 68 minus 28, all over 200. And what fraction, before you reduce, what fraction do you have? 120 over 200? You can also divide that one by 4 and maybe more. Divide by 5. Let's see if you can divide by 5s. Divide by 20 maybe. Once you reduce it, 30 over 50 would work, and then you can divide top and bottom by 10. Right? What do you get? 3 3/5. Guys, either you get very comfortable with reducing or you have a fraction key with a scientific calculator, but you need to make sure you work on your reducing.
I just use my brain for that one.
Good. Yes. Hustle, please.
Is it still
Okay.
raining?
Guys, questions? Okay. Number 3, Alex, there's some paper right next to you. Do you see it? Right next to you. Can you bring me one, please? Thank you. Thank you. All right. I'm running out of room. And instead of moving to the back page for me, I'm just going to get a different piece because if I move to the back, I don't want to have to keep flipping. So I'm just going to do it here. So what number are we on? 3. Probability. It is a car or van. Am I still using the word or? Yes. Is or, look back at your formulas. Or, is it the overlap or where I add and then subtract the overlap? Okay, so probability it is a car plus the probability it is a van minus the overlap. Okay, all right. So how many cars do I have total? 100. Plus, how many vans do I have total? Minus, and it's going to be all over 200. What's the overlap? Is there overlap? Okay, there is no overlap. Why? Because what can we say about a car and a van? They are what? Mutually exclusive events. They cannot happen at the same time. So on the overlap, I'm going to put up here if it exists. Because is there always going to be overlap? No, if the two events are mutually exclusive, there's no overlap. Okay, so 100 plus 32 minus 0 is 132 over 200. Try to divide by 2 or 4 or anything bigger. By 4. And keep going if you can keep going. 33 over 50. How many of you are using your fraction key on your scientific? Is it helpful?
Yes. Oh, yeah.
Like it? All right. Number 4. Okay. What's the probability it is a car and white? I believe I asked about that one earlier. Car. Now we're using the word and. What are we looking for? The overlap. Them happening together. What's the probability it is a car that is white? 52 out of 200. Does everybody see where I got the 52 from?
Yes.
Write this down with us. Why I'm talking to you. Okay. All right. Does everybody see that we have 52 white cars? That's the one we said earlier had the most. Okay. Divide by 2, by 4, or divide by 2 twice. Okay. Divide by 4. What do you get? 13 over
50.
50. Okay. Next 2. Nope. Not yet. Number 5. What's the probability it is a truck and a van? Now we're looking for a truck and van happening at the same time. And I said earlier, is there such a thing as a truck van? No. So is this still looking for overlap? And there's not yet. Does the truck and the van ever overlap? No. So it is 0 out of 200, which is just 0. Okay. Okay. Now, remember what I said. In this particular parking lot, we're not looking in the whole world. There are not only 200 vehicles in the whole world.
What about the UPS?
Okay. Listen. Listen. We are looking only at this parking lot with the 200 vehicles that are only cars, trucks, or vans. That's it. We're not looking at the whole world. We're not looking at the UPS parking lot nor the mail carrier parking lot. All right, listening. Why is it 0? Because these two events are what? Mutually. And whenever it's mutually exclusive, is the and always 0? Yes. Okay. Number 6.
Unless
But that would not be mutually, unless it was what?
We have cars like that.
Not in this world. Not right here in this parking lot. We're only in this parking lot, guys. Remember that. Okay, number 6. Probability not van. I'm going to write it another way you may see it. You remember I talked about that tilde? Not van, that means not. So if you ever see that, it means not. Not van. Complement. Does anybody...
Wait, the tilde is not?
That means not. Yeah, not van. Or the complement of a van. This means it's everything except the van. How many vans do I have?
32.
How many vans do I have?
32.
So how many not vans do I have?
168.
So 168 out of
200.
200. I'm going to show you the math formula. Bless you. Does everyone agree it's going to be 168 out of 200?
Yeah.
I'm going to repeat why. Not vans. If there are 32 vans, how many non-van vehicles do we have?
168.
168 out of 200 are non-vans. Do you agree?
Yeah.
Okay. Doing it the mathematical way, because you'll need to know that formula. Does anybody remember? We subtract the probability it is a van from what number? The total, which for us, probability would just be 1. Okay, what's the probability it is a van? 32 out of 200. And what's 100? Is that 200 out of 200? And what's 200 minus 32? And did it end up being what we said earlier? Yes. Should it make sense with the formula, and should it make sense just looking at the chart, at the table, the graph, whatever it's called? All right. Do reduce this. You can divide by 2 or 4 or something bigger. Keep going until you get as small as you can get. 8. It does divide by 8.
I got 21 out of, like 21 over 25.
21 over 25 is correct. Okay. Now, these next two, 7 and 8, are going to be a little different, but on the test. Is everybody ready? Okay. Yes. Go ahead. Okay. Okay, number 7. What's the probability that it is a truck? Nope, I lied. Sorry. That it is a van. Probability it is a van given it is black.
Why is it given?
Why is it given is correct. This is a totally different type of probability. I need everybody paying attention. Now, there are formulas. I'm not going to give you the formula. I'm just going to tell you how to use it with the chart, because that's what we need to know for now. You can learn your formulas when you get into statistics, or if you take statistics instead of advanced math. Okay, so listening. I'm going to show you how to use your chart, and we're good. Is everybody ready? The probability is it is a van given, is the key word here, it is black. Everybody listening. Whenever there's the word given, you are no longer dealing with the total population. Did everybody hear that? You are no longer dealing with the 200. Read it. It's a van given it's black. What population do you think you're dealing with? The van's population or the black vehicles population? It's a van given it is black. That's why I circle this one. You always circle the one at the end. That is your total population now. How many black vehicles are there? 80. Of those 80, your eyes are zooming in on just those 80. Of those 80, how many of those are what? Are vans. How many? 16 out of 80. Okay, so when you see these, you focus on the last one. That's your denominator. So you focus on only everything else is gone. Only the black vehicles. Out of the 80 vehicles, how many are vans? 16. And that's it. And you reduce it.
Well, it's easy. It's 2/5.
Okay, 1/5. Try it again.
Or 1/5.
Yeah,
Oh.
it's okay. Next one. Probability. It is white line car. What the heck does that line mean?
Or. And. I don't know.
It's probably or.
It means
Oh, means given.
given. So when you see the vertical line, what's the probability it is a car? I'm sorry. What's the probability it is white given it is a car? Okay. Am I dealing with the total population? Which one do I circle, the first or the second? Okay, so that's my denominator. So I focus in on the cars. Now I'm focusing in this way. How many cars do I have?
100.
100. So of those 100 cars, how many of them are white?
52.
So 52 out of 100. Does that make sense? All right. Go ahead and reduce. You can divide both of them by 4. 13 25ths. Thank you.
Good work, Stephen.
Okay. The last thing I want to talk about is dependent and independent. Give you those formulas, and then we're going to get started. Does anybody need this still?
No.
Okay. So I am going to talk about dependent and independent events, and then we're going to get started on the work.
Good. My hand is caught. There. Mobile.
Okay, guys, I want to first talk about what it means to be dependent or independent. So we're just going to do some talking, and then I'll give you formulas. We're going back to our deck of cards. Okay, we have a standard deck of cards. Shuffle it, and I ask, what's the probability you get a heart? What's the probability you get a heart?
1 out of
How many hearts are there?
13.
13 out of
52.
52.
52 pickups. Have you ever played that?
Okay, listen. Now, what if I said, you do this first, you take out a heart, you place the card back, and then I ask, what's the probability you pull out a diamond? Actually, I'm going to change the diamond to a 4. Okay, listening. Now, you took out the heart. You put that card back.
54
So how many 4s are there?
4.
Out of. Why is it still out of 52? Because what did you do with this card? You put it back. Okay. Now, I'm going to change this number to a 5 only because I don't like that there are both 4s. Okay, would it still be 4 to 52 for the 5?
Yeah.
Yes. Okay, so what if I did not replace the card? I took out the first one. What's the probability it is a heart? 13 out of 52. I did not replace it. What's the probability it is a 5?
4.
Okay.
4 out of 52.
Is it still out of 52?
48.
It's out of 51. Even if I change this 5, let's pretend this 5 that was a diamond. Do diamonds and hearts overlap at all?
No.
No. Okay, so what's the probability I take out a heart first?
13.
Out of 52. I do not replace the card. What's the probability it is a diamond? 13 out of 51. So, when I do not replace the card, is that dependent or independent? If I do not replace the card, does this probability depend on this probability?
No.
Yes, because I took a card out and I did not put it back. Does that make sense?
Yeah.
So when would it be independent? If I had done what with the card? If I had replaced it back. Does that make sense? Okay. So replace, not replace, independent, dependent. Okay. So what I'm going to give you the formula right now. I'm almost done. How to prove events are independent or not. I'm just going to put not. What does it mean if they're not? They're dependent. Okay, so I'm going to give you the formula. We're going to get started. Is everybody ready? Okay, probability of A and B happening equals, if it equals 0, that proves the events are what? Mutually exclusive. We're not dealing with mutually exclusive right now. Equals the probability of A times the probability of B. Okay, so what this means, you're going to be given a Venn diagram. We're going to do one together in just a little bit. I need you guys paying attention. You get a Venn diagram or whatever, a chart, whatever it may be. You're given information and you're trying to prove an event is independent. If this happens, it is independent. If they do not equal each other, what would you say? They're independent or not? If they don't equal, it is not. If they do equal, it is. So I'm going to erase this or not because this test is for independence. Two events are independent if this happens. Stop the talking. Now I'm going to give you one little quick way to write it. Are you ready? What is this for us? Looking at your previous page of notes, what did we write for this part? Look at your previous page of notes. A and B was what? Just the overlap. So if your overlap equals the product of A happening by itself times the product of the probability of B happening by itself, if those two things are equal, we say they are what? They are independent. If they do not equal, they are not independent. Does that make sense? Okay, this we're going to work with today. I will tell you it's probably what gives the most problems to kids on the test, so you want to make sure you know this. Put notes aside, take back out your packets, and we're going to get started. No. All right, everyone have their packet out?
Yep.
Okay, we're getting started. Car and blue. You can keep your notes out if you'd like. We're using these tables. When we're using frequency tables, we use this here. What does and mean? Overlap. So we're looking for a blue car. Is that such a thing in this chart?
40 over 130.
40 over, I'm going to put that in my workspace because that's what you would do on your test. 40 out of 200. Cross out your zeros. Does 4 go into 20? 1 over 5. And in your answer column, you would put 1/5. Workspace, answer column.
Would it be 40 over 130?
40 over, where are you getting the 130? Because right here?
Total of cars.
That's if it says given. Does it use the word given at all? It's only when it uses the word given that you're no longer dealing with the total population. Got it? All right. White or truck. Look at your notes. So what do we do with the word or? Add and subtract the overlap. Okay, how many white vehicles do I have? White vehicles are 100. Plus, aren't white vehicles 100? How many trucks, total trucks do we have? And then is that it, or do I subtract the overlap? And how many white trucks do I have? 22, and it's all over. If you want to make 3 separate fractions, can you? Are they all going to be over 200?
Yes.
Yes. So 100 plus 70 is 170. Minus the 22 is 100 and that's in your workspace, and then you reduce. Divide everything by 2, maybe even a 4. I think a 4 would go into both of them. Or you use your fraction key. Has anybody done it yet? 37 over 50 once you reduce? Okay, I'm going to do one more with you, and then you're going to work. Not red. Use your formula, which 1 minus the probability that it actually is red, or you use your chart. How many red vehicles do you have?
40.
If you have 40 red vehicles, how many non-red vehicles do you have? 160 out of 200. Does anybody want me to show you using the 1 minus? No? You just know it's 160 out of 200? And then I would cross out the zeros. 4 divides into 16. 4 also divides into 20.
4/5.
4/5. All right, keep working.